Hello, linear algebra. How are you? So, as I think about my screencast today, I think that you are all itching for the shortcuts now that I've made you use that big, beautiful brain in your head. So, I offer you these shortcuts with reluctance. Okay? All right, a couple of proofs here. These are super easy proofs. Algebraically, it's very easy to show that that the magnitude of a cross product squared equals the right-hand side. A dot squared is subtracted from magnitude of u squared times magnitude of v squared. This statement right here is extremely easy to prove. It's just very, very messy algebraically, okay? In fact, if you really feel like doing this, be my guest. It's just a pain, algebra. There's nothing really difficult, okay? If you really want me to start this, the algebra in class one day to show you how disgusting it is, I will oblige, but just trust me that it's very easy. Anyway, taking this statement, we know that cos theta is u dot v over magnitude of u, magnitude of v. All I did in my next step in blue here is I solved it for the dot product, multiplying both sides by the denominator, and I just squared both sides, okay? And what that gives me then is an expression here that would equal this dot product squared. And by substitution, I'm going to substitute dot product squared into here. So follow the yellow arrows. And when I do that, you see that magnitude of u cross v squared equals da, 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 da. Here is that substitution. Okay, then here's just some algebra. I factored out a common factor of u squared v squared right here. That leaves me with 1 minus cos squared left. And as you know from trig, 1 minus cos squared equals sine squared theta. So what I get is u cross v squared equals mag u squared times mag v squared sine squared theta. Square root of both sides. Da, 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 da. Here you go. This is what you physics folks use, which is fine. Just understand something, this shortcut, it doesn't give you the components of the cross, right? So every shortcut has limitations. So this shortcut gives you the magnitude of the cross. That's a nice one. And look at my red. Remember how I've been asking you to find the area of a parallelogram? Remember, it was on the test. And it was on the review problem set. And the way you do this is you say, oh, I know the area of this shape is going to be this base, which is the magnitude of v, times the height. And the way that we'd found the height was you found the angle between. Then you'd say sine theta equals h over magnitude of u. You'd use this, right? And you'd say then that h equals magnitude of u sine theta, right? Very good. So the area of a parallelogram equals base, magnitude of v, times height. And base, magnitude of v, height is u sine theta. So all I substituted in here was height for height, which gives you magnitude of v, magnitude of u sine theta. Oh my, but that just equals the magnitude of u cross v. Look at that. So from now on, when you are finding the area of a parallelogram defined by two vectors, you can just say the area is going to be the magnitude of v cross u. Ha ha ha, yay! And obviously, if you're asked to find the area of a triangle defined by two vectors, that would just be the magnitude of v cross u divided by 2. And that, ladies and gentlemen, concludes this reluctant offering of shortcuts. I guess I could always do the, I can tell you, I might as well tell you. We were doing in class when I last saw you the volume of a parallelepiped, right? The volume of a parallelepiped. And yes, this is how I shorthand it. A parallelepiped. Right, we were doing it the longhand. The shorthand shortcut, and maybe I'll have you prove this. The volume of a parallelepiped defined by three vectors u, v, And W is equal to, it's awesome, it's really great, the absolute value of the scalar triple product of U dot V cross W, which is pretty awesome too. And I mean, in all honesty, you can think about this proof. It's very easy reading. This proof is not very difficult at all. It's very similar to the proof I did above, but that's a great little shortcut. All right, young and nimble minds. Here's your homework from your textbook. We'll go back to our textbook. And what's nice about kind of our little detour into the world of equations of lines and planes is that really sets a nice stage for us as we enter very soon the world of multivariable calculus, which on my teacher page I wrote, Dorothy, or is it Dorothy or Toto? We are not in Kansas anymore. All right, everyone have a fantastic weekend, and take care of yourself, take care of your minds, take care of your bodies. Goodbye.